section 8.7, we'll take a look at something called set notation. We'll look at Venn diagrams, mutually exclusive events, drawing Venn diagrams, and we'll start with sets. So in math, a set is a collection of items or numbers, and we often use Venn diagrams to organize sets. So if it's set notation, you'll see these curly brackets right here, these little wavy lines, and you would put everything that's in set A within the curly brackets. So if we take a look at our Venn diagram, we're looking at all the numbers in set A, and that would be the 1, the 6, the 5, the 3, and also the 4 and 7. So it's everything in circle A, that's set A. And likewise, we can look at what's in set B, it's everything in circle B, 4, 7, 8, 9, and 2. So that is called set notation when they use the curly brackets, and inside the curly brackets is everything in that set. Within Venn diagrams, we also look at something called the intersection and the union. So the intersection, it refers to the numbers that appear in both or in all of the sets. So if you take a look, and there's a symbol for intersection. It's this upside down U. And so if you see A intersection B, what it means is A and B. What's an A and B? And so an easy way that I remember that is that the upside down U, it looks more like an A. So A and B. What's in sets A and B? And I guess where they overlap. And so 4 and 7, those are in sets A and B. Oops. So we'll put 4 and 7 are in sets A and B. Okay, we have this other word that we use when categorizing things in a Venn diagram. It's a union. A union refers to the numbers that appear in any of the sets. So what this means, and again, the symbol for a union, it looks more like this, and it means or. Intersection means and. Okay, so again, and is, they're in A and B. When you see the or, it means they're in sets A or B or both. Okay, so basically when you see a union, it means everything. Everything in those sets. Okay, so if I say what's an A or B, we would say it is the 1, the 6, the 5, the 3, the 4, the 7, the 8, the 9, and the 2. Whoopsies. So or means everything in any of the sets here, like A or B or both. So again, intersection means and, it has to be in both. Union means or, it's in one or the other, or both, it's everything. And then we'll take a look at what a complement is, and you'll see it written many different ways. You might also see it written as this little prime right here. So complement means not in those sets. So if I say what's not in set A or B, well, we can do this a few different ways. I wonder if I give you some examples. No, I don't. Okay. So I might say what's not in set A, so these mean not in set A, and it's everything not in set A, you would see, all right, what's not in set A, it is the 6, the 7, the 6, the 2, the 4, the 3, the 9. So not in set A is 3, 9, 7, 6, 2, and 4. I could say what's not in set B, so it might look like this, or it might be this, or it might be this. All those three things mean not in set B. And not in set B, okay, let's recircle. So not in set B would be the 1, the 6, the 3, the 9, the 4. Okay, so you have to know these words, and we'll practice more. But again, the upside down U, it looks more like an A, means and. It has to be in both sets. The union means everything. And then when you have the complement, it means not in that particular set. So let's do some examples. Write the set notation for the following. Okay, so let's do A and means has to be in both. A and C. Okay, so we'll look at A. Here's A. We'll take a look at C. Ooh, I should use my highlighter. Okay, so highlighter. Okay, so here's everything in set A. And then we'll look at everything in set B. Let's pick a different color. Oh, C. Okay, so this is saying what's in set A and set C, and that would just be, I don't want that color, 5 and 6. Oh my gosh, my curly brackets. All right, so 5 and 6 are in A, set A and set B. All right, the next one is or. Okay, so or means in set A or C or both, so we would include all these numbers here. 1, 4, 5, 6, 3, 7 is an A or B or both. Okay, the next one again is and. Okay, I guess right here, let's change colors. So this is in sets A and B and set C, so we're all three overlap. Okay, so let's highlight again. So here's everything in set A, everything in set B, and everything in set C. So we're looking for and means where it overlaps for all three, and that's just one number this time, the 6. Don't need a comma. There's my curly brackets. Okay, so the next one is not C. You might also see it as that or like that, but it means not in set C. So everything not in set C would be for the 1, the 9, the 2, and the 8. So here's everything not in set C. Ooh, I don't know what that was. Okay. The next one, we'll switch colors here. Yeah, I don't know what color to use. All right, so this is an A and B. Okay, so an A and B, if we highlight, so here's everything in A, here's everything in B. So an A and B is just going to be that number 6 again. And the last one, what's an A or B or C? And or is everything. So it's going to be everything except 8 right there. So 8's the only one not inside those, so it's going to be everything but 8. So that would be a 1, a 4, a 5, a 6, 9, 7, 2, and 3. All right, so or means everything. Let's take a look at the next example. It says the events to the left are mutually exclusive. What does it mean if events are mutually exclusive? It means they both can't happen at once. They don't overlap. They cannot happen at once. Can you think of events that are mutually exclusive? And like it could be your first hour class and your second hour class because they both can't happen at the same time. Some people say you can't sneeze with your eyes open, so maybe that's you. Those would be mutually exclusive. So it's two things that can't happen at the same time. You can't be a 9th grader if you're also a 10th grader. Mutually exclusive means they're separate. There's no overlap like there was overlap in this Venn diagram. If they're mutually exclusive, there's no overlap. Okay, drawing a Venn diagram. It says 30 students were asked if they have a cat or a dog. Okay, so here's my sample space right here. And people can have cats and dogs, so I'm going to go ahead and overlap this, and we'll do cats and dogs. It says 20 students have a dog, 15 students have a cat. 60% of those that have a dog also have a cat. Draw a Venn diagram. All right, so I'm going to start with that. The 60% of those that have a dog also have a cat. So here, how many students have a dog? 20. So if we do 60% of 20, it's 0.6, or 60% times 20. If I multiply that out, clear this here, my calculator. All right, so I'm going to do 20 times 0.6, and that would be 60% of 20, and that would be 12. So 12 students have a cat and a dog, so I'm going to start there. 12 students have both. So then how many just have a cat and how many just have a dog? Well, if 20 students have a dog total and 12 have a cat and a dog, we would do 20 minus 12 to figure out that 8 students have just a dog. And then in the full dog circle, you can see there's 20 total dogs, or 20 students that have dogs. All right, then it says 15 students have a cat, and 12 of those have a cat and a dog, so 15 minus 12, 3 students would have just a cat. And then total in the cat circle, you see there's 15 that have a cat. And let's see, so it says 30 students were asked total, so we have to make sure that, well, maybe some people don't have a cat or a dog. So if we add up 3 plus 12 plus 8, what do we get? 3 plus 12 plus 8. That's 23 students have a pet. So 30 minus 23 is 7. 7 kids don't have a cat or a dog. So here's the Venn diagram that we've created. And now with that, let's figure out the following probability. So when you see P means probability, what's the probability a student has a dog? So that's everything in the dog circle. So there's, if we add those up, that's 20 students out of 30 have a dog. And you can write a probability as a reduced fraction, as a decimal, or as a percent. So it's about 67% or 0.6 repeating or 2/3. So 2/3 of the class has a dog. All right, what's the probability of a dog or a cat? Or means one or the other or both. So it's everything within the circles, one or the other or both. So if we add those together, that was 23 students out of 30. And you can leave it as a fraction, or we can get the decimal or the percent. So the percent is 0.766 and so on, which is about 77% of the class has a dog or a cat. What's the probability that the student has a dog and a cat? So this is where it overlaps, and that would be 12 out of 30, which we can write the reduced fraction. What would that be reduced? It's the biggest number. We can divide them by 6, right? So 2/5 of the class. 2 divided by 5 is a decimal. So we could also write that as 0.4 or 40%. All right, so your assignment today is you're going to want to click on the quizzes link and complete 8-7 Venn diagrams.